is to use this time first and foremost to help you, just to tutor if you've got questions. Okay, and then after we do that for a little bit, or after if we just answer your questions the whole time, that is just fine. My next goal, the next thing I'll be doing is just showing you some problems, so you just have a chance to see me work some of the problems that are from the section, and maybe just help you learn a little bit. So that's the goal. So if you don't make it to one of these, you'll see these things being recorded. All right. Now I'll mention this. So the schedule today, if you should find the schedule in Canvas, right, under the schedule button. It will show you what sections you should be covering. And what will happen is, I'm just looking at the schedule right now. Today we're doing 6.5, and tomorrow you need to be working on 6.6. And there'll be a Chapter 6 test because we're done with Chapter 6. Okay, so that's going to be rolling right there. You've got a couple quizzes. I've moved all the quizzes to extra credit. All the past and future quizzes will be counted as extra credit towards your final grade. So hopefully that'll help you a little bit. But that's where we're at right now. But the schedule is really important. So make sure you check that out in Canvas. Okay. Any questions on any of that? Okay. All right. So let's just do this. Let's just jump in, and I'll work a couple problems from this section. We're not going to do a full-fledged lecture, obviously, but I do want you to see a couple problems from this section from 6.5. Give me a plus in the chat box if you're seeing my screen here, where I usually write stuff. Just give me a plus if you're seeing that. An equal. I guess that's supposed to be a plus, right, Rose? Okay. All right. So let's just jump in. I'll show you a couple problems so you can get used to them. So we are doing what is called factoring by special products. Let's do this because I'm curious. On a scale from 1 to 10, with 10 being the best and 1 being the worst, how is my audio and my writing? I'm just curious to see how well this internet connection is working. If everything's going great, it should be a 9 or a 10, or if it's really sketchy and you can't hardly understand, maybe a 1 or a 2, somewhere there. Okay. Okay, so let's look. So here's what we're looking to factor in this particular section. All right. We're looking at what the key is we're looking at things that have 2 terms. Give me 1 second. Yeah, so we're looking for things that have 2 terms, right? So 1 term and another term. That's the first thing. The other thing, so when you're asked to factor something, you count the terms, and there are 2 terms. So if it's 2 terms, you're going to maybe consider these approaches that we're talking about in this section. The other thing you're going to look at is, are the terms perfect squares, or are they perfect cubes? And so you can see here that x squared is a perfect square, right? It's x squared. 36 is a perfect square. It's 6 squared. So we have a perfect square minus another perfect square. So those are all the things you're looking for. Basically what we call this is the difference of squares. If this is the pattern that you see, then it's called the difference of squares. Okay? Now, like I said, as we go along in this process, feel free to unmute your mic and ask a question at any time. I also try to keep one eye on the chat, but I may miss it. But stop me at any time. So anyway, I a difference of squares. Two things subtracted, both of them are perfect squares. Well, here's the thing. When we factor this, it's going to factor into two binomials. One's going to be x minus 6. The other one's going to be x plus 6. You can see where I got the x's. X times x is the x squared. Where did I get the 6's? Minus 6 times 6 is negative 36. And you can check that out if you FOIL it, right? If you check your work by FOILing it, first is x squared, outer is a 6x, inner is a minus 6x, and last is a negative 36. And look, these two cancel each other out. They disappear, right? And so it's called a difference of squares. All right, let's try another one. Maybe something like this, just another simple one. X squared minus 100. You can see that it's a difference, subtraction of something squared minus something else squared. And all you got to do is identify what's being squared. Of course, the x is being squared, but also 100 is 10 squared. So x minus 10 and x plus 10. Right? And that's the factorization. It's really kind of nice. We don't have to unfoil and do the possible first, possible last. We just recognize the pattern. Now, these can get a little more complicated. Maybe we have something like this. 12 minus 3a squared. Okay? Now, the challenge here is to remember, anytime you factor anything, you first want to pull out common factors. And so this one does have a common factor of 3. So 4 minus a squared. There it is. Right? Pull out a 3. Now, before we pulled out the 3, when we were back over here, we couldn't do anything really with it. But when you pull out a 3, you now have this, and this is a difference of squares. Something squared minus something else squared. And so it will factor. The 3 comes along. That's now part of the answer. But the 4 minus a squared will factor into 2 minus a and 2 plus a. And there it is factored. One last example for difference of squares, just a little more complicated. 4y squared minus 81. Everything is a perfect square. You need to know your perfect squares, right? So 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on, right? That continues. You need to know those numbers so that you can recognize them. And at some point, you'll see an 81 in that list, right? It's 9 squared. No common factors, but look, everything is something squared. So we're going to have a 2y and a 2y. We're going to have a minus 9 and a plus 9, because that's how we got the 81. Right? Okay, so those are some factoring by special products. All right, those are, and the special pattern we're looking for is a difference of squares. Give me a plus in the chat if that's making sense to you guys, would you? Okay, looking good. So let's look at the next kind of special things that we're going to run into. Here we go. X cubed minus 27. Now, again, two terms. And what you notice here, though, is we don't have perfect squares. Obviously, the x cubed is not something squared. We have instead perfect cubes, right? So x cubed is x being cubed. 27 is 3 cubed. And so now we have not differences of squares as our pattern. We have what we call difference of cubes. Right? And so everything is cubed, and it's a difference of subtraction, right? Now, you might want to take a note. What are the perfect cubes so that you recognize them? 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. And you could keep going up to about 1,000. Obviously, there's a lot fewer perfect cubes. It looks like that anyway. But you need to be able to recognize them so that you can realize if you're dealing with perfect or difference of cubes. Now, let me write this. Let me go back to the difference of squares and squeeze this in. Here's the formula for difference of squares. If you're ever factoring a squared minus b squared, it will factor into a minus b times a plus b. So that's the official formula for difference of squares. All right. Difference of cubes. Here's how it looks. This is how it works. Your first factor is going to be x. Makes sense because that's what was being cubed. Minus 3. Right? I always like that first factor because it's just the two things that were being cubed. The x and the 3. Your next factor, and this is just something, this comes from a formula you just have to memorize. You just have to remember this. The next factor is going to be, you now have the x as x squared. So here you had just an x, now you have an x squared. Makes sense because if you multiply those two together, you get the cube. Also, at the end over here, you put a plus 9. Now, where did the 9 come from? That's a 3 squared. Minus 3 squared. Okay? So, this second factor is going to be this squared at the beginning, this squared at the end. Right? Now, what goes in the middle? The product of those two things. But it's going to be a plus. So, a 3 times an x is a 3x. And there it is. That's the factorization. And notice you get a binomial times a trinomial. Right? So that's what's going to happen when you factor a difference of cubes. It's going to be a binomial times a trinomial. And this trinomial, this thing with 3 terms, we can't factor it any further, so we don't even need to worry about it. Okay. All right, let's do that one more time. So let's do y cubed minus 64. And factor that. No common factors, so we don't have to worry about that. We just now jump in and we say, okay, it's going to be a y minus 4. All right? Why? Because the y was being cubed and 64 is 4 cubed. Then for your trinomials, you're going to have a y squared and you're going to have a 4 squared. That'll be plus. And in the middle, you're going to have 4 times y, so plus 4y. All right? And there it is. Here is the formula for difference of cubes. If you're ever factoring something cubed minus something else cubed, it will factor into a minus b times a squared plus ab plus b squared. And that's the formula for difference of cubes. All right, so that's one you just have to remember. I've tried to, as I went through these problems, tried to demonstrate the pattern so that maybe your life, it'll be a little easier to remember. Okay. All right, so give me a plus or a minus or an equal sign. Thumbs up, thumbs down, or thumbs sideways in the chat if that makes sense. On the difference of cubes. It's a little more complicated, for sure. All right. Let's go to this next. Let's do something like this. X cubed. X cubed plus 125. So now we're talking about sum of cubes. All right, so now we're talking about the sum of cubes. So you see that you see about something cubed and something cubed, but now you're adding them. So how does this factor? Well, it's going to look real similar to what we just did. Here's what it's going to be. X plus 5. Okay, the previous when we were doing difference of cubes, it was x minus 4. Now it's going to be x plus 5. far as the components go, it's the same as the difference of cubes. In fact, let me write that. Here's the sum of cubes. A plus B, A squared minus AB plus B squared. So you see that they're the same, except the signs here and here are different. Notice the last signs are the same, right? The two pluses are equal. But if you're ever factoring a difference or a sum of cubes, those are the two formulas that you use right there. Okay. All right. Let's try one more. Let's do something like this. 125 y cubed minus 8x cubed. All right. So we look at that and we say, okay, that's a difference. And we also see that everything is something cubed. Obviously, the x and the y are x and y cubed. But 125 is a 5 cubed and 8 is a 2 cubed. So when we factor it, we're going to have a 5y minus 2y. Those signs will always match, by the way. 5y minus 2y. And then a 5y squared, so a 25y squared at the beginning. And a 2y squared at the end, so 4y squared at the end. And then a plus 2y times, sorry, this should be an x. This is a 2x. So this becomes a 4x squared. And then the product is a 10xy. There it is. So that's a little more complicated. But you can see we're just following the same pattern that we've designated before. Right. Okay. Do you guys have any questions on those examples? So this just gives you a few more things to look at. Now remember, you can watch the lectures in Canvas, right? And I showed you how to do that in a couple different places. So you can watch full-blown lectures from another instructor. What we're doing here today, today we had plenty of time to go through problems. But, in the future, it might be that we're answering a lot of questions, right? So we want to be prepared. Make sure you're watching those videos. My suggestion is this: watch the videos, try the homework if you can, and then bring your questions to class. Let's use this as a chance to give you specific help on specific questions that you have, right? So just like visiting a tutor. That being said, there are tutors available online. I'll post that information in Canvas, get that out to you. But that's where we're at. So, are there any other questions? Do you guys have any questions before we call it a day? All right. Well, we'll see you on Monday, I guess. So thanks for checking in, and I encourage you to attend these things as much as you can. And stay safe out there, and we'll talk to you later.